Hello everyone and welcome to this section. This section we're going to perform region of interest in an actual Python environment. All right, so let's take a look. First of all, we're going to load our libraries as we have done several times before. Here we're going to open up an image, which is kind of, like a basic image that can show kind of, what to expect when you are driving, when you're having a self-driving car, okay? And then we're going to show here simply the image. Let's take a look and see what's going to happen. So that's my image, all right? So again, here what I can see is I can see, okay, like I'm driving the car, the camera is centered, and here I have kind of these two lanes. And what I'm looking for, I'm looking for this region of interest. That's my region of interest. Obviously, I'm not looking at the objective, obviously, is to detect lane lines, okay? And I know that if the car is centered, highly unlikely I'm going to see any lanes, for example, in this area or in this area or in the sky. So what I need to focus my efforts to look for the lane lines within this region. And that's what we call it, region of interest. Okay. All right. Sounds great. Let's see how can we do this. Okay. And let's get the height. Let's get the width. And let's show as well the image so we can actually see the dimension. So here we have around 540 by 960. All right. Next step is we're gonna convert the image from colored image to a grayscale image. Again, we can use CV, it's OpenCV, and then we're gonna use CV2.color BGR to gray. That we're just gonna convert the image from colored format to a grayscale format. Let's do it and let's actually view the image. And again, that's my image in a grayscale. And then here I can as well get the shape of the image, which is 540 by 960. If you go up, it's pretty much the same as well, 540 by 960. However, here this was a colored format, and that's why if you don't think I have it here, but for example, let's assume that I wanted to get the dimension of my image. So I'm gonna do this dot shape, and if I do this, we're actually gonna show me it's 540 by 960, but there is 3 dimensions indicating BG and R. We covered that before, and I'm assuming you guys are experts by now. When you do grayscale, you just have one kind of, one layer out of this, which is 540 by 960, the same as here. Okay. The next step is we're going to perform the region of interest masking, okay, which is really fun section. First of all, we need to identify what we call the region of interest points. Again, we're going to do that manually, which is pretty much the same as we have done before when we did a perspective transformation. We actually went there and we selected the points, right? We're going to do the exact same thing, but here we're going to define the region of interest that I'm looking for, okay? So let's assume that I want to, for instance, pick this point, pick a point somewhere in here to indicate that I'm going to basically select this region, and I'm going to go down here to the corner. So simply put, I'm going to need this point, all right? And I need this point, and I need kind of 2 points in here, somewhere in here, okay? Again, it's trial and error, you can try it. And here pretty much I try to summarize them here for you. So first of all, I have 0 and height, which means I have, again, that's my origin. So I have 0.0 and height, which means I want to go down to 540. So 0 and 540, that's my first point, looks great. Then last point, okay, which is again width and height, which is simply this corner, which is the last point. I went all the way to the width, went down all the way to height, and that's where I'm gonna get this point. All right, what about the other 2 points? Obviously, these 2 other points, we're gonna have the same Y per se. So I'm looking at 300 something, 350 for instance, just to have that height, right? And that's why you will see that's my height, 350, pretty much the same. However, they have different X's. They have different X dimension. Why? Because I'm looking at a point here, which is, let's say, had around 400, okay, right? And I'm looking at a point here, for instance, which has, let's say, 550, okay? And that's pretty much my region of interest first, all right? The next step is I'm gonna create, again, my mask, all right? So what I'm gonna do is I'm gonna create a black mask, just an image with all black pixels. And then I'm gonna use the region of interest and define and put ones within my region of interest. Then I created my mask. Simply put, I have pixels, all of them zeros, except the region of interest, which I'm interested in, I'm gonna make it ones. And then once I do this, and it with the image, you're good to go. Then you masked your region of interest. All right, perfect. So let's take a look. So first of all, we're gonna do np numpy.zeros like, which is simply creating an image which is simply all black, okay? which is the size of the image gray, okay, which is again my image. I'm going to create a mask, and that mask has all zeros, okay? So before running the entire thing, let's actually run cell by cell. Let's take a look. So here, that's my first step, and simply I created a blank image, all right, where if I actually do this, and let's take a look, you will see that simply I created an image kind of with all zeros. That's pretty much it, with the same size. If you want to take a look at the size, we're just going to do blank road shape. They're going to give me exact same size as my image gray, 540 by 960, and it's all zeros. The next step is I'm going to do fill poly, which is, kind of fill polynomial. I'm going to use the image, which is all zeros. I'm going to use my region where I wanted to put 255 in it. And that's why I define my region of interest here. I'm going to put it here, and then I put 255, which is indicating I'm putting number white in it, in a way. Okay? All right, and that will define my mask. And then what I'm going to do afterwards, I'm going to use my image, which is the original image, which is image gray here, along with the mask, all right, and do what we call it bitwise operation, bitwise ANDing. Okay, if you guys remember the AND gate, I'm going to do ANDing just to give me my masked image. All right. Okay, let's run it, and that's my masked image. Let's take a look. That's my image again, shape, and that's my image. All right, looks great. That's what I'm expecting. Obviously, you guys can go and change, the dimensions if you want. For example, if you want to change, for instance, let's assume that I wanted to shift these points up. Okay, that means I'm going to change the Y direction. Let's say change it to, instead of 350, I'm going to change it, let's say, to 300. And let's see what to expect. Or maybe make it even more aggressive. Change it, let's say, to 200, just to get a feel of what I'm going to be expecting. So I'm going to change it to 200 and 200. And let's run it again. And that's it. You guys can see, it's just, you can actually change the points or the dimensions. You can increase, you can decrease the region of interest. You can actually zone in, zoom out. You can even make these points a little bit closer if you're not interested in checking any areas around the around both lanes. All right, and that's pretty much all what I have for this section. I hope you guys enjoyed it, and see you in the next section.